Welcome to ClueCon Weekly. Join us every Wednesday to learn about the latest cutting-edge developments in the real-time communications industry. ClueCon Weekly is brought to you by FreeSWITCH Solutions. Get support and professional services directly from the creators of the FreeSWITCH open source project, solving your issues in the most efficient, stable, and scalable way possible. Get the FreeSWITCH advantage. Visit freeswitch.com. Also brought to you by ClueCon, the premier technology conference for developers by developers. Join us every summer in Chicago. ClueCon kicks off on Monday with our annual hackathon, The Coder Games, followed by 3 days of technology-rich presentations discussing telecom, WebRTC, and IoT from developers around the world. To learn more, visit ClueCon.com or call 877-74-CLUE.
And welcome to ClueCon Weekly. Today is the 11th of November. And this week we're going to do a special community episode. So what that means is we're going to have Abby. She's going to be joining us, doing an extended blog post, talking about a whole bunch of cool stuff today. We've also got Mike Malvarutis. He's going to be joining us with both Mike Jarris and Brian West, answering a bunch of questions from the community. So you guys stand by for that. First, let's welcome Abby for the news. Abby, how are you doing, ma'am?
I am doing great. Thank you for asking. Hi, everybody, and thank you for joining us today on ClueCon Weekly. So if you have any questions during this call, please comment in the YouTube, HitChat, Slack, or IRC channels, and we will try to answer them during this call. This is especially important today because we're going to be talking about a lot of technical things with FreeSWITCH. So if there's anything that you would like us to answer, now would be a great time to get in touch with us because we'll try to answer them live in the next hour. If you are watching us on YouTube right now, please give us a share. Also, feel free to follow us on Facebook, Twitter, Instagram, and LinkedIn to stay up to date with all the crazy things the FreeSWITCH team is doing. If you aren't already subscribed to our newsletter, you can get subscribe to our newsletter on our Facebook page under the tabs on the left side of the page. In other news, it is never too early to start thinking about ClueCon. So everybody mark your calendars because we're back at the Swiss Hotel on August 5th through 8th. So we're back on our regular schedule. We are also now open for sponsoring. So if you think your company would be a good partner with ClueCon, we have a large availability to a very technical audience, and it's also a lot of fun. So if you're interested in learning more about that, you can email Sharon at freeswitch.com. Our next FreeSWITCH training is actually tomorrow, but it's not too late to sign up. So if you're interested in some beginner level training, you can sign up for that on our website under our products tab. All right, that's all the announcements I have for now. I'll see you guys in a little bit. And we're going over to the community corner, I do believe.
Yeah, let's get Jersey Mike in here. Mike, how you doing today?
Good. So as Ken mentioned earlier, we have a little bit of a new format. So we'd like to hear what you think about it. And let's start. So today, our first one is we're going to talk about NAT and firewalls, and Mike's going to answer the question. So Mike, What's the deal with firewalls? How come they always block our stuff?
Because that's what they're designed to do. I mean, it's true. Firewalls are designed to keep bad things from getting to you. And most people who administer firewalls, which I counted myself as one many years ago, don't really have an understanding of VoIP or how it works. And they get very afraid when you say you have to open huge ranges of ports. That's a very scary thing for them. And we can talk a little bit about why that actually isn't scary. Yeah, let's talk about it a little bit. So the way VoIP works is there's usually two different things. There's signaling and there's media. And signaling depends on which protocol you're using. Lots of people use SIP. We have this thing called Verto. They use a set of ports. And media happens for each call. There is one or more sets of ports that you communicate on. So at worst, let's say you're doing an audio-video call like this, you could be talking on each side a port for receiving RTP for audio, RTCP for audio, RTP for video, and RTCP for video. In complicated, like room system kind of situations, it could be even more than that. So that's 4 ports on each side.
Let me ask you this: why does video appear to work so much better with NAT than regular SIP?
Doesn't. My guess is that the reason you're saying that would be because you're used to using video on WebRTC a whole lot. And WebRTC has some extra things that make media work a little bit better with NAT than traditional kind of RTP media. So let's talk about those a little bit. So like I said, there's 4 sets of ports on each side. And those get allocated out of these huge ranges of ports, which is a little bit of a security by obscurity approach. But the reason it's not a big deal to open all those ports is the server's not actually listening on them unless there's a call allocated to them. So having those ports open doesn't make any difference. So what WebRTC gives you, what makes NAT less of an issue with WebRTC than it is with other things, is there's this thing called ICE that is kind of built into WebRTC media. And what ICE does is instead of just exchanging IP port pairs for each of those 4 different things, is it sends a whole bunch of candidates. It said, I might be here, I might be there, I might be here. And there's an actual like crypto negotiation that happens to figure out for sure where you are, and there's a password involved.
Right, so you get all the candidates. You get the internal candidates. You get the external candidates. You get all the different pairs, right?
Yeah, and in the worst cases, you also get candidates for a thing called turn if you have that configured. And turn is like a media proxy. You put a turn server on a box that has no NAT on it. And turn can speak UDP, RTP, can also speak TCP, RTP, which most things out there other than turn can't do, can translate between them. So you can have a device that has all UDP blocked, and it can go to a turn server, come to that turn server and come back down to you like regular UDP, RTP traffic, and you're none the wiser. Just a little bit.
And a lot of these libraries, they'll actually hard code turn servers in the source, right?
Yeah, on Verdo we don't hard code them, but we make it pretty easy to set them up. But the things that everyone's used to using all the time, like FaceTime and Google Hangouts and all these things that are kind of built into our devices, all of these use a similar approach where there is, even if it's inside of encrypted streams, all of them use some sort of turn-like relay and something that exchanges candidates for media. Most of them are actually doing essentially the same thing WebRTC is doing, sometimes inside of another stream cipher. What we know about FaceTime from the bits that have been publicly talked about is that it's essentially the same sort of approach inside of, I think, an RC4 cipher on top of everything else. So Skype back in the day did something very similar where they had media proxies that they could bounce off of. But it was all basically the same approach. So that's ICE. And then on WebRTC, there's another layer of security added to it called DTLS SRTP. And that's similar encryption to what regular SRTP is, but with a different key negotiation method that kind of does a bunch of the negotiation and key rolling inside of the media side of things, as opposed to depending 100% on the signaling side of things, which the previous ones did. Some people like it, some people don't. It is standard in WebRTC and significantly more default secure than anything else out there previous to it. without the overhead of having to set up and check things, which something like ZRTP would handle. ZRTP is probably a little bit more secure than DTLS, SRTP, but not without a cost. So back to the NAT side of things, the ICE features of WebRTC make that all work so much better. ICE is available in many just SIP clients as well, like Counterpass Bria 5 has built-in ICE support. Maybe not all of the tricks. There's some more tricks in WebRTC that instead of using 4 ports, tries to stuff it down into less ports. That sometimes makes NAT handling a little bit easier, also makes the amount of processing on the server a little bit more, so we don't love those things, but some of them are all right. Like the combination of so a feature called RTCP MUX that combines the RTP and RTCP onto a single port is a feature we love. It's less ports to juggle. It's actually easier for us to handle. There's another feature called Bundle that tries to stuff audio and video together. It's less interesting to us. It's a little bit harder for us to deal with just because of how well that can scale in a server application. In a client application, it's great. FreeSWITCH as a server tends to be happier on something either not behind NAT or behind a very clean, like a symmetric kind of NAT. When you get into your restricted cones and things like that, tends to be a lot more difficult. Not impossible, but a lot more difficult to handle.
But FreeSWITCH as a whole handles NAT very well.
Yeah, I mean, we've spent a decade kind of working around different tricks to get around different things in NAT. So on the media side, another thing that we do is on so many devices, configuring devices properly is a rampant problem. No one knows how to do it. The defaults aren't great. So frequently...
When you mean devices, you're talking about firewalls and stuff.
I'm talking about client devices, soft phones, hard phones, anything speaking SIP to you. I'd say, depending on the implementation, 20 to 80% of your traffic is going to be misconfigured for NAT unless you control the configuration of those devices. It's that bad out there in the wild. If you're just a SIP provider that lets anyone send stuff to you, you're going to get a huge amount of garbage. And it's not maybe so simple what kind of garbage you get. It's going to be all over the map. Garbage in the RTP side, garbage in the SIP side. Misconfiguration is rampant. So,
yeah, and so it's really the engineering components that pull it all together and make sure and automatically repair it, right?
Trying to make it all work automatically is the trick. So we've developed a ton of tricks. So I'd prefer to do something that uses ICE more nowadays because those things just work, but and work more securely. But like an example for things that don't support ICE that we do is we have a feature called autocorrect for RTP. And what that does is essentially we start sending to the address we think we're sending to, which may or may not be right. And if we start receiving RTP traffic from a different address, then there's some threshold about when this can happen. It's a very short window and requires a certain number in a row and things like that. So there's some defenses against this being abused by people trying to steal your media stream for nefarious purposes. But essentially, if you just send us the wrong address, when you start sending to us, we're going to figure it out and switch and start sending back to you in the right place. We do something similar in ICE, but we take advantage of the authentication that happens in ICE to actually do that autocorrect in a secure way. So even if your ICE candidates are wrong, we can still kind of adjust and do the right thing in a secure way. So that's even better, but it's a perfect example of things we do to adjust to what's out there in the wild, wild world of VoIP.
Right. So it basically it auto advances through the different candidates and finds one where the stream actually works.
Well, so it attempts to figure out the right one by a combination of preferences on our side, as far as what we're going to send and try to verify to. But also, we listen for them to send to our candidates, and when we start receiving these ICE pings, there's a negotiation process. Then we know, okay, that one's actually live. There's a whole negotiation process that happens with ICE. That's part of the standard that does all this. So, yeah, and then we can also do some changing on the fly later. Those are a bit more complicated topics, but there are some features to do that as well.
So should we be looking at the SDP?
So a common problem we have that we hear people reporting is people say, hey, I've got one-way audio, it's a one-way video, where they set up a call, they expect it to be you and me talking to each other, audio and video, and I can hear you and you can't hear me. So the problems here, I mean, they're interesting to troubleshoot, particularly from a provider standpoint, because half of those problems are the fact that your Bluetooth isn't connected and you think that you should be hearing me through that, but actually going to your computer speakers and your volume on those are turned all the way down. That's actually the majority of the problems are things like device selection, even on mobile. It happens to me all the time. My phone talks to my GPS in the car over Bluetooth. The volume on that's turned all the way down because it drives me nuts. I get in the car, I'm talking, all of a sudden the call's gone. They can hear me fine, but my volume's turned all the way down. I can't hear anything they're doing. These problems are rampant. That being said, there are definitely one-way audio issues that happen from NAT. And those typically happen, like you said, should we look at the SDP? Inside the SDP, you're going to have the addresses that it attempts to connect to for media. In a non-ICE call, it'll just be, for each media, audio and video, maybe image, you'll have an IP port pair. For something with ICE, you'll have something called candidates, which will have a list of them. Like I said, we see it less in ICE, although it's not unheard of where the wrong candidates come through. In the ICE side, the typical issue would be a misconfiguration on the FreeSWITCH side. We have a list of ACLs that let you filter and prioritize which candidates to accept. And the defaults are for kind of external addresses, but if you wanted to support a mixed network of internal and external addresses, you need to set those up properly. So that's one thing. On the non-ICE,
I once had to debug. Here's a really, because you're talking about, what is it, 1812 or something, RFC 18, I don't know the exact numbers.
1918?
1918? Okay, so I had a NAT issue one time where in the LAN they were using, it was one-way audio, and they had publicly addressable IPs in their LAN.
We've seen that and far worse. We've seen carriers using what they thought were private addresses for a carrier NAT kind of situation, but those addresses were actually routable addresses that belonged to someone else. So we had a customer on one of these carriers trying to actually send to one of those addresses, and only to that address block. It wouldn't work. And the carrier's like, no, that's to us. And it's like, no, really, that's not you. You guys are using someone else's address space. I've seen customers use public assigned address space as their internal address space instead of RFC 1918 addresses. I've seen customers using carrier NAT address space inside their networks that their carrier was also using. So there was conflicts there. I've seen everything.
And that's the type of stuff like you could have the best engineering in the world, but it doesn't. That's hard to detect.
It's pretty hard to detect. And I mean, this was back in a previous position where we were doing a lot of PBX stuff, but it's a rough day when you have to tell a customer that their network engineers managed to use someone else's address space and they actually had to renumber their entire network in order to actually work. I'm just happy that Brian West had to deliver that message and I didn't. It was a rough day. But I believe eventually they did, or they just split the VoIP stuff off to a different subnet that they used an actual IRC 1918 address. One of the two. It was a rough fix, but it was what they had to do. You want to talk about signaling? We talked a lot about media and what the different NAT things are, but signaling.
What about, well, so wait, no, wait.
More media. Good, go.
What about we talked about we did ICE. What about NAT PMP and all that stuff? What's the deal with that?
Okay, so there's two different protocols, one called UPnP and one called NAT PMP. And both of those protocols are designed to automatically, magically, with zero touch, configure your firewalls. These are generally implemented on consumer devices. I'll be honest, I think that they're kind of frighteningly insecure. And for an actual commercial purpose, I would never use these protocols. But because...
How does the protocol work? It just like announces to open up these ports, right?
all it does is basically unsecured from the inside tells the firewall, open up ports. So
yeah.
anyone on your internal network can open up whatever they want. That's from a actual controlled network standpoint a terrifying idea. It's really useful
because it sends it out as like multicast, doesn't it?
I can't remember what's actually on there because we use libraries that do it, and I've never actually looked closely at the other side. But it's really useful for your mom getting a VoIP phone up and running. For that phone to have these features built in and just set up all the NAT mappings for you. It is terrifying for a corporate implementation to have ports magically open. But this is the other side of that. But I can't open up 16,000 ports. That's insecure. It's really not. You're opening up 16,000 ports or 32,000 ports to a box that isn't listening on those ports unless there's actually a call up, at which point you would need those open. Firewall administrators are under the impression that number of ports have some relation to how secure or insecure something is. A bird just hit my window.
Because you want to know, it's almost like they have the concept like if they're opening up the ports, it's like they're port forwarding or something. Right?
Correct. Well, I mean, technically they are, but they're forwarding it to a box that probably isn't listening to any of those ports unless it actually is and they need to be open. So it's basically not getting blocked at the firewall, it's getting blocked at the box. And dropped immediately because that port's not even being listened to. So it's just as safe as blocking at the firewall. There's no additional risks. It's just scary to people who don't understand VoIP and understand what these ports are for. So I've had these conversations many times trying to explain these things. It doesn't make it any more secure to block those ports to make the range smaller. All it generally does is make it a problem that you hit later down the road when you grow to a certain size and you go over your previous port range and you start running out of ports. So
okay. And then ALG or not to ALG? That is the question.
I once saw an ALG that helped.
But it was a unicorn ALG.
I mean once, as in my entire career, one time have I seen an ALG that helped. Every other time
That's why it'd be a unicorn ALG.
yeah, right. Literally every other time I've seen an ALG, it only breaks traffic. The only reason this ALG helped was it was a consumer device that used some sort of restrictive half cone NAT nightmare, and the ALG was actually well integrated into the NAT and opening up the NAT. So it essentially did the rewriting of the SIP packets and the opening of the NAT ports the way a NAT PNP would do, and did it correctly. I have literally only seen this happen one time. I'm shocked that it was the case, and we had to turn off all of our NAT stuff and only send the internal addresses to it for it to even work.
So what's the deal with the hardware manufacturers? Because it's been a decade of people always saying disable ALG. Why do the new firmware releases just have it? And why is it always so bad?
Because it's a low priority, and once they've sold the device, there's no motivation to make something that works well. And typically not having it on, devices at the end devices handle it properly. The only place this comes into play is when you're doing really evil NATs, like ones that intentionally change ports around from the inside to the outside. There's really not a whole lot of reason for it other than when you have a lot of devices on the inside and only one IP on the outside. And then you only should have to use different ports when what is requested isn't available on the outside. I guess they're just lazy, or there's some view that being cryptic and complicated makes things more secure. That isn't true, but there's some people who think that. It just makes things more complicated. What's worse is when you have things that won't even let stun go through. So NATs that are at least a little cooperative will map based on the internal port only. Difficult NATs map both on the internal and external port and destination. So it means you can't even do a stun lookup from that port to figure out what your external address is going to be and get the mapping set up. Honestly, I think it's just people are designing these things that don't understand how protocols work and don't care. Manufacturers are out there to sell devices, not to have them work well afterwards. And these are very low margin devices, so unless you're making millions of them, it's just not worth it to do a good job. The more commercial side firmwares that are higher featured tend to have features that work better. But your commercial CPE device that are delivered by your local cable modem provider or local cable provider, there's just not a lot of.
And we've seen that, like the cable providers all of a sudden will push out firmware updates.
Yep.
And when they push it out, they'll have ALGs enabled on it, and something that has worked forever, all of a sudden, just boom.
I'm not so convinced that isn't intentional, because the cable providers, at least until the last couple of years, made a lot of money on triple play. So they're making a lot of money on their voice services. So breaking other voice services was in their best interest. Now, doing that in a way that was, I'd say, traceable could, come into potential, net neutrality or antitrust kind of issues. Doing it in a way that's deniable seems like it's in their best interest. So, I'm not surprised that, let's say, AT&T used to deliver a Motorola DSL modem that had a ALG that there was no way to turn off, but just in the AT&T firmware. That doesn't surprise me. That ALG was horrible.
I've seen AT&T actually block 5060.
Yeah, so that doesn't shock me because it's not in their corporate best interest to allow that stuff through, and to break it in a deniable way and just give horrible customer support so they can't fix it works for them. I don't have any knowledge of that, but it wouldn't shock me. They certainly have no motivation to make VoIP services work really well on their DSL service. They have a great product that I actually appreciate, where they deliver VoIP over MPLS. Works great. Why would they make it easier for people to use other services? Doesn't seem like they have a lot of reason to. So there's all of these kind of financial incentives, like everything, that drive these horrible technical decisions. We've seen similar kind of things happen in the standards bodies where decisions are made that seem totally contrary to any common sense, driven by one party who has a financial interest in not having to rewrite hundreds of stacks of protocols, and to stay using old, antiquated things that don't serve needs as well. We've definitely seen strong pushback against certain moving forward kind of ideas in, say, the WebRTC working groups. For example, the whole fight about video codecs was very much driven by people who had strong investment in gear that did H.264 and didn't do VP8. So VP8 was out there, and then a group who was going to be on the losing edge of that advocated strongly to not be on the losing edge of that. I mean, it's totally understandable. It does make moving forward with technology more difficult, but also technology is implemented by people with business interests, and those business interests matter to the people who are implementing it. So sometimes those interests also conflict with each other. So it's a process, and standards processes are difficult and not always result in the best results. On the NAT side and the ICE handling, I think they came up with a good solution. But some of the other solutions were more political and individual business interests than technological interests.
What about just taking like RPort and that type of stuff and remote IPs? And so the FreeSWITch has some settings for that. Right?
Yeah, so we've talked a lot about the media side of things. The signaling side of things is a whole other set of issues. Let me start with we have another protocol that's not SIP. We call Verdo. Verdo is a client server kind of protocol that we use just for WebRTC, where the web browser connects back to to the server, and all of the signaling is over a pinned up WebSocket. That protocol is great for NAT because there's no NAT involved. It's all over a single connection from the second your web browser connects and says, I can take a call, to when you close your browser. We also have some cool functionality for being able to reconnect a session, say if your browser crashes or even if the server gets shut down, we can reconnect those. That's great for NAT. The downside of that is it's very client server. There's no way for the server to reconnect to the client. The client has to do all the heavy lifting. And it's also a little bit more expensive because it requires this pinned up connection. On the SIP side, it is much more complicated. SIP supports UDP and TCP and TLS, and in some implementations, even SCTP. And it supports that, UDP, which is connectionless, where you have to know where you're going to connect back to. Over TCP, which is connection-based, but the way SIP works, it's essentially connectionless. It needs to be able to reconnect. So as a result of that, all the signaling protocols need to pass IP addresses and how to get back in touch with each other around inside of the packets. Well, that's fine until you start going through a bunch of NATs and those addresses change. And you need to do the right things to figure out the right addresses throughout there. We do a lot of those things as far as, let's say we get a register in, and the register says the contact is an RFC 1918 address. We have an ACL that lets you specify which addresses are clearly not right, and we can compare those with the IP import we actually received from. And we can actually just ignore what you sent and use the address that it actually came from instead. Not for register, but for an invite and a SIP transaction, the feature RPort you talked about does exactly that. It basically says, ignore what I actually told you, just send it back to me. This works for most devices. There's some old Cisco devices that used to send from a different port that it wanted to receive on. Those are mostly gone these days. But that's the simplest forms of NAT handling that we do. We do have some progressively more aggressive ways to do it. Those tend to break with some devices and not others. But RPort's just enabling RPort in the device is the most accurate way to handle that. What else you got?
Oh, so what role does the FS path play?
FS path. FS path is a URI parameter that we kind of magically handle behind the scenes and strip off and use it so you can insert a proxy into the SIP signaling call path while still using our regular kind of dial string methods. So in an FS path, you would take you would URL encode it if you're doing more than just like an IP. You can do IP : port, semicolon transport equals, whatever kind of transport you want. And internal to FreeSWITCH, we're going to decode that and look at it and say, okay, this is the next hop proxy we're going to send it to. We're going to send the SIP just like you wanted to before, but instead of sending it to you, we're going to send it to a different location.
But this can also help out NAT as well.
It can. For example, when I was talking about some of the tricks with registrations, what we actually do is we save the contact address that you said to send it to, but with an FS path tacked on the end, and then we send it where the request URI is the contact that was in your original registration, but the FS path translates to where to actually send it to. So it lets you do some things magically, but also manually just specify the next hop proxy right in your dial string. Gives you a ton of flexibility about how to route things.
So what else can we do from a signaling perspective to kind of address those NAT issues, just like as a quick 30-second blurb?
What else can we do? Some proxies NAT support, like Chameleon OpenSIP's NAT support is usually pretty excellent.
And completely programmable, right?
And, completely programmable. That being said, just like our NAT support, theirs can get very complex as far as how much you rewrite and how you handle it. So putting proxies in between handles a bunch of things. It can let you handle NAT and load balancing and some security stuff up front, such as DDoS protection. That's one way to handle it. Turning your device RPorts on and actually being responsible for configuring your devices is another way to handle it. Yeah, then you get into NAT keep lives. I've seen many people. I recently saw someone with 9,500 registrations going every 5 minutes to FreeSWITCH. That's an example of something that I would recommend putting a proxy in front of. And there's, I'm not sure which proxy support it. There's something called forward registration, where essentially the proxy will handle all of the back and forth registrations very quickly. And on the back end, will send us a register for 8 hours. And if they actually lose registration, they'll send us an unregister. Takes a
that's mid registrar.
Yeah, mid-reg. That's another great feature to take advantage of.
Okay, well, thank you, Mike. And now we have questions for Brian.
Where's Brian? There's Brian.
I'm here. What's up, guys?
Brian, I can't fax from where I am.
Well, that's because you're in 2018, Michael. You just can't fax from there. We have email.
Wait. So why can't fax just die? When will it?
This has been something I've asked before, and there's a reason it can't. It's a training issue. You have people and processes in place that have been there for decades, and people won't change those processes, so you have to make it work. And sadly, we do faxing over IP with audio sometimes. So it's like, let's just make it more complex for no reason. But yeah, it's something that's a requirement still. Hopefully it'll go away soon.
So there's been some new changes in like 1.6.15 and 1.6.16. What changes have we seen within ModSpan, DSP, and all that stuff?
There's
Talk about that.
Behavior changes. I'll start with the behavior changes because I actually sent an email about this. By default, now FreeSWITCH will not accept a T38 reinvite because that's considered a codec, and we probably shouldn't just blindly accept and change that unless you enable it. And we also do graceful fallback of if we do a rejection. For example, we're starting a
that's important,
phone call.
Right?
Yeah, it's very important. So if we start a phone call with G711 and it wants to switch to T38 and we reject it, we can gracefully maintain the phone call now and continue with G711, and you have that control. In addition, we'll both directions, inbound and outbound, that's graceful now.
And so how does that increase the success rate?
Well, it allows you to have more control over what you're doing at your point on your network. So you know what your network's capable of and what your endpoints and your customers are capable of. So you can programmatically prevent, say, a T38 reinvite from coming in and being passed through to a customer where maybe their device just doesn't do it right and it will cause the fax to fail. This allows you those types of controls that you didn't have before. Previously, we would just take it and go, all right, here's T38 fax. And in some cases, that might fail because even if you receive a T38 reinvite and you properly switch, the remote end that initially sent you that T38 reinvite may be broken too. So you
right.
and then not accept that or even switch, because if they're broken, they'll break you, and it's not good.
Well, one of the big challenges, I guess, is like, who's the initiator, right? Who sends out the initial invite?
That's the fun part about that. There is a argument on that one. There's two mindsets. It's whoever's doing the transmission or whoever initiated the fax and has those capabilities should send it, but that's not always the case. So there's no clear like RFC or anything of who should send it, because sometimes you'll receive a G711 fax and it could have switched to T38 had you just sent the reinvite. So there's no clear path on who is supposed to do what there. So you kind of have to pay attention to the source and destination phone numbers.
Yeah, and so here's the problem too, because if you're just going to have a failure if it's out of sync, especially on T38, right?
Correct. So there's a couple other things we added around that time as well. There's some stuff that'll allow resizing of the sent or received images to match the remote sending or receiving terminal, because you may not realize this, but Bob sent you a PDF that has this awesome thing you want to fax over to Alice, and you go to fax it, and you don't realize that that page width is actually 49 feet wide. So you probably don't want to have we would have in the past actually tried to send a 48-foot wide fax, and most fax machines will go image too big and reject it. So you're able to turn on image resizing.
So it didn't work because I want to send everyone my business card 48 feet wide.
Yeah, right. But no, what it'll do, it'll allow you to resize it so that the fax is at least successful. Before, it would just reject it and not do anything and not give you a whole lot of information. The remote in just rejected the image too large. And a lot of people wouldn't realize, oh, well, this image that I'm trying to fax is 49 feet wide. Well, because it's a PDF from your printer and they were actually trying to print something 48 feet wide. So, and then there's another thing that was added recently. We can do color faxing. Most of your new multifunction.
Oh, that's important.
Yeah, it's very good for real estate agents. Love it. I don't know which ones because most of them have email. But most multifunction printers that you buy these days that have fax functionality can send and receive color faxes.
Well, if you wanted to send a picture of a house, you're not going to have really a good probability of a sale if it goes black and white, right?
Right, that's true. And there's cases where maybe that is the only way you can get something to that location because they may not have internet there. They have a phone line. That's it. So but the thing is, if we send a color fax, right? What happens if it's a non-color printer? Well, most, like I said, multifunction printers that are color have this capability. We can only go so far here. At some point, you just got to throw your hands up in the air and go, I'm going to email it. That's the best thing to do. You accept a PDF, right?
Wait, so what's the secret when it comes to sending large, not like large format size faxes, but like, let's say it's like a 300-page fax?
Don't. That's my personal recommendation. You're not going to send that. I can't think of any requirement, but you can do it. You need to track how many pages were successful. So if you restart, you need to be able to set which page that you start that fax with on the retry, which we do have all of the facilities in ModSpan to allow you to do that. You can tell how many pages were successfully sent, what page number you need to start on the fax. You can set that. So if I want to initiate the fax again and I made it to page 30, I want to start on page 30 just to make sure they got that page, then you can set that option, and those are documented as well. And it'll start the fax at that page within the document, so you pick up where you left off as close as possible. But don't fax 300 pages. That'd take forever.
Isn't that what FedEx is for?
I'm pretty sure FedEx would beat the fax.
It's funny because when people always test, they send a one-page fax.
And I'm going to tell you one thing you'll be like, oh, faxing works. Yes, it works, but you have a NAT problem because that first page makes it through, but then we never get the ACK, and then that page is less than 30 seconds, and then you're like, oh, it works. So it's that wonderful NAT problem you were talking about earlier where you got recovery on time or expire, but the fax made it through. So.
But the reality of fax is we're never really going to get rid of fax, right? Because there's compliance, there's compliance layers where it's required. You have HIPAA, and it might be fax to email, right? But in the end, it starts out as a fax.
The fun part about things like HIPAA, you have people writing and drafting these regulations and rules that we have to follow for security of this data that absolutely do not understand that how this technology works, and that faxing is not really that secure. So, I can fax it to you, but I can't email it to you, even though that email left my mailbox. All TLS all the way to your mail server and delivered to your inbox via TLS was more secure than faxing you a document. And that's the truth. But the people writing the laws and rules didn't understand technology. This is why some of these people shouldn't be writing laws and rules.
Yeah, that's actually that's a really good point. That is an excellent point. And so a lot of this fact stays around as being for these compliance layers, and there is a way to securely send documents without any question, but even just base email, like
yeah,
for
like
instance,
making no effort
just
in this
using
day and age.
Gmail. Yeah,
Right,
just
making no effort in this day and age. It's like I was trying to send somebody a document that had some things in it they needed to look at, and I'm on Gmail, they're on Gmail, and I didn't want to bumfuzzle around with the GPG key because they couldn't figure it out. It wasn't going very quick, and I was like, I need to get this information to them. They're Gmail, I'm Gmail. Here it goes. If anybody gets it between here and there, they deserve to get it at that point. They probably have a court order for it. So
okay. Well, thank you, Brian.
You're welcome.
Always good to have you on there. Always good to have you. Because we always get Mike. So Brian, you gotta come in a little bit more.
Yep.
Okay, and then to Abby for blog stuff.
Obviously, you're not paying attention. Abby's had to step away because Mr. Jarris and Mr. Brian ate up all our time today, and it's already that time of the day, guys. So, so it's one of those things. It's actually, that's not a bad thing because there was a lot of NAT information there from Mr. Jarris and various ways we can address those things. So if you missed any of that, go back and rewatch it because that's a lot of good, valid information there. And we had Mr. West here. Thanks, Brian, for covering faxes. And as I think Brian said it best, Brian, how do you send faxes again?
I can't fax from where I'm at.
You just send them over to
All right, guys. And let's see here. Mr. Maveritas, thank you very much for helping these guys out with all their questions today. So if you guys want to get questions in for Mike to, ask Brian or Mr. Jarris or any of the other guys from the team, be sure you're emailing those in, to the mailing list. Ask on, let's see here, the community Slack channel or HipChat or any of the other forms of, things that we have here for communicating with the team. And they go through those every week and find the good questions or find any questions and proxy them in here so you can get answers from the experts. Join us next week. We'll be back here having all kinds of fun stuff going on. Watch for the announcements on that. Be sure you follow us on Twitter, like us on Facebook. And for you guys watching on the YouTube, click that subscribe button and then click that little notification button and you'll get alerts on when we go live or when we post new videos. We'll see you guys next week.
You've been watching ClueCon Weekly. Tune in every Wednesday at 12 p.m. Central. Keep up with the latest happenings by subscribing to our YouTube channel, follow us on Facebook and Twitter, or visit us at FreeSWITCH.com.